We start with the V first. Okay, kamu dah ready belum untuk belajar?
Dah.
Okay. At the end of this chapter, students should be able to define electric potential V. This one is the electric potential. Dia tak ada sebut energy pun. So this is the difference between U dengan V. Kalau U tu dia ada energy. Define and explain equipotential lines and surfaces of isolated charges. So equipotential line ni actually potential ni dia ada, kita boleh lukis gambar juga. Macam electric field tu kita boleh lukis gambar, potential pun kita boleh lukis dia punya diagram. Used for a point charge and a system of charges. Okay, so normally for the calculation we'll be using this formula. Okay, and then we have delta V, delta U equals to W. Okay, these two maybe kita tak sempat kot yang E dengan F tu. Okay, what is electric potential? Electric potential of a point in an electric field is defined as the potential energy per unit positive charge at the point in the electric field. So this sentence actually referring to this formula. Potential energy, U, per unit positive charge. So what does it mean by positive charge? There's sometimes per unit test positive charge. Yeah. Positive test charge. So test charge ni dia ibarat something yang olok-olok. Dia it's just a test charge. This charge exists so that you can test dia punya direction. Nanti saya explain more. Or it's defined as the work done per unit charge in bringing positive test charge from infinity to that point in the electric field. Jadi saya nak buka sekemas ni, lemas pula. Okay, so the work done per unit charge in bringing positive test charge from infinity to that point in electric field. Okay, so normally we'll be using this definition instead. So these two referring the same thing. One is U over Q naught, another one is W over Q naught. Okay, easier to memorize is the first one, obviously. It's pendek je. Easier to understand actually than the second one. So it's up to you guys lah, nak prefer yang mana. So I just want to explain the second one. So what does it mean here is that work done per unit charge in bringing a positive test charge. Okay, normally we write formula for work like this. Work is equals to Q naught delta V. The Q naught is the test charge. Okay, this is the test, dia tulis kat sini. So this is the test charge. Saya ulang test charge ni macam you are putting the charge to test the situation. Dia bukannya, dia tak wujud pun actually. Tak ada tak wujud Pelik pula aku cakap tak wujud. Anyway, kita pergi dulu. Kalau kamu tak faham, nanti kita pergi balik. Okay, let's say if I have example. Okay. Example, I have a positive charge in isolated system. Dia by itself, ada satu dekat sini. And then you want to bring positive test charge from infinity to that point in the electric field. Okay, this positive charge, this one will produce a electric field. An electric field lah. Dia ada field lah dekat keliling dia. Potential referring to work done to bring positive test charge. I put it over here as Q naught from infinity, R equals to infinity, to that particular point. Alamak, betul. So I want to bring this test charge, let's say, closer over here. This one is what we call, let's say this is point A. So this would be the distance of RA. So if I want to find the potential here, will be this one aja. Oh, this one is RA. I already write this one. Okay. So from this equation, delta V here represent final minus initial. So if you are using the work punya equation, if your equation got work, delta V represent final position minus initial position. So I'm going to rewrite it again. So this is the important concept. There must be final minus initial for work. Initial is at infinity. Final is at A. So if I want to write the equation of V actually equals to KQ over R. Kamu tak jumpa lagi equation ni, jadi kamu jumpa. But when the R is at infinity, that means R is very big. It's very far away from the test charge. The potential is equals to 0. It makes sense lah. R very big, potential 0. So basically it doesn't have any effect by this positive charge. So it's located over here. So it goes closer, it will increase, and then over here you have a specific value. So your work will be equals to Q naught V at A minus 0. Okay. Minus 0 because this one is at infinity. So you left with W equals to Q naught VA, which is basically this one. So the definition is that the work done per unit charge in bringing the positive test charge from infinity to that point in electric field. So this is just the definition. But the keyword here is from infinity to that point. You have to write. Kalau tak dia memang salah. Okay, we discuss more on how to calculate V after this. So don't worry about that as well. So it is a scalar quantity. The unit for electric potential is V. Okay, so for any question. Okay tak ni? Hello, kamu bersama saya ke tidak? Adakah saya bercakap sengsang?
Ada.
Ada Kau tengah buat apa? Makan biskut? Okay, equal potential line and surface. So this is how you draw lah. Sometimes in exam they
Tengah
might ask you
fokus
to...
tengah fokus.
Tengah apa? Okay, alhamdulillah. Okay. Okay, one more thing. Sementara saya ingat sekejap lagi jangan lupa bawa lab coat. And then make sure kamu pakai formal lah. Jangan pakai slipper pula. Okay, so... Okay, so how to draw the equal potential line? So it is important for you to be able to draw as well lah. Sometimes they combine. Dia suruh lukis electric field dengan equal potential lines. So equal potential line ni actually represent potential punya lines lah. It's defined as the locus points that have the same electric potential. This is the example. This one is for point charge. Bentuk dia macam ni. For uniform electric field, bentuk dia macam ni. Okay, syarat dia yang pertama, kamu punya equal potential line ni mesti 90 degrees to the electric field. So yang ni yang electric field yang last week kita dah belajar how to draw E tu. The dotted line, the dashed line ni adalah V. Equal potential line lah. This one is equal potential line. So it need to be perpendicular to the electric field, 90 degrees. Dia tak akan bersilang. Satu sama lain tu tak akan bersilang. And then kalau the uniform equal potential due to uniform electric field, spacing dia sama. Okay. The closer the spacing, you will expect the potential to be higher. Contohnya yang ni. Dekat lagi, V dia higher. So, lines kamu tu, in this case, dia adalah rapat-rapat. So, this one is for positive charge. Notice that this one is for positive charge. Okay. I'm going to explain this one first and then we go to the point charge. Yang this one, electric field, dalam example, most of the time if they are talking about uniform electric field, biasanya, bukan biasanya, dia memang punca dia daripada two metal plates. So two metal plates so sometimes they didn't draw in exam lah, dia tak kasih gambar two metal plates. So I suggest you to draw it yourself. Macam mana nak lukis? Kita lukis dua plate depan dengan belakang. Kita buat lagi sekali, tak apalah, saya dah malas nak padam. Like that. And okay, bayangkan benda ni tegak, cantik, baris. Okay, the electric field comes from this side, go into that side. If you think back about the positive charge, macam ni kan, electric field dia going out. So in a way, this one represent the positive charge. This one represent the negative charge. So saya dah explain kan macam mana lukis E tu kan. Cuma saya nak tunjuk balik je lah. Sebab yang ni biasanya penting bila dekat 1.4 nanti, subtopic 1.4. Okay, and equipotential line, since this one is uniform electric field, equipotential dia pun uniform spacing. Okay, yang this one dia jadi circular lah, dia 90 degrees to the electric field tu. Okay, ni karakteristik lah, dia
Faham
perpendicular. Dia perpendicular to E, decreasing of the potential closer, maksud dia stronger. No two equipotential surface can intersect each other. This one is another important thing. Okay, kenapa penting benda ni? So dia punya application dia to indicate the change in potential. Contohnya dekat sini A dengan B, walaupun kamu nampak satu kat sini, satu kat sini, dia actually lies on the same equipotential line. Dia masih line yang sama, cuma dia circle kan lah. So what does it mean is that V at A is equals to V at B sebab dia atas satu line yang sama. Macam ni kan, A dengan B satu line yang sama, B dia sama. Okay, at C here, dia dekat line berbeza, so you expect the potential to be different. Kenapa penting kamu nak tahu potential dia sama ke different? It's actually because of the work. So if you go back to the equation work, so actually subtopic ni kita sebenarnya tekankan pasal work tu sebenarnya. At the end of the day, kita nak cari work biasanya. So work done, if I want to move my charges, saya ada, let's say saya letak satu positive charge kat sini, saya nak gerakkan dia daripada B ke A, potential dia kat tempat yang sama, so delta V dia sama dengan 0. Sebab delta V is VA minus VB kan. So delta V equals to 0. When delta V is equals to 0, work done is equals to 0. So if you want to move a charge from B to A or A to B or any points on the same equipotential line, no work done is needed. Tak perlu lakukan kerja. Dia bergerak. Nah, kalau kamu nak gerakkan dia ke C, and then you have to calculate lah. Since delta V is not equals to 0, ada work done. Macam mana nak kira? Nanti kita pergi tengok masa dekat subtopic work. Okay, this one since electric field is constant, V is constant as well. So we assume dekat V ni sama je lah. VA, VB, VC tu sama. Apakah ini? Okay. This one is just that they want to point out, since this one is scalar, right? One is positive, one is negative. If I substitute Q is positive and negative, then I have a positive potential and negative potential. Apa maksud positive and negative potential ni? Sebenarnya tak ada makna apa pun. It just that it indicates that it comes from a negatively charged particle. Itu je. Kalau V kamu ada nilai negatif, maksudnya dia datangnya daripada negative charge punya particle. It's not really that important in terms of, it's not really significant in terms, dia tak ada physical significance, tapi kamu kena tulis. Kalau tak tulis, salah terus. Dan satu benda yang dia dah keluarkan daripada kamu punya syllabus is actually graph ni. Tapi this graph is actually very important for you to understand the concept of potential. Okay, here, example, if I have a positively charged particle A, position, so my V is actually directly proportional to the 1 over R. Because K and Q is constant. Q ni kan dia tak berubah, K dia pun tak berubah, is constant. It depends on R but inversely proportional. But this one is positive. If you look over here, the V is directly proportional, inversely proportional to R, but this one got negative sign over here. So macam graph 1 over X. 1 over X, actually if you want to draw the graph, it will be like something like this dengan ada partner dekat sana. Kalau kamu ingat tau, at max dulu. So the radius cannot be less than 0. Dia takkanlah less than 0, tengah-tengah tu 0 je. So kita ambil yang side ni je. Kalau negatif, graph dia 1 over X is like this. Terus tu, again kita ignore that part. Okay, the key thing here, okay, saya tak tulis dia punya unit, so I'm gonna write the unit as well. It's just a reminder, since this one, you have a K, so if you want to calculate the potential and you are using this formula, you have to write in SI unit, especially for R. R ni biasanya small number, cm ke mm. So you have to change to meter and then you can substitute. Kalau ada negatif dekat Q, masuk juga nilai dia. Okay, why this one is significant about this graph is that for this case, if I want to bring a charge from further out closer, that means potential dia adalah increasing. Ke sini increasing. Lagi jauh decreasing. Okay. And this one, as R is increasing, they actually increasing as well. Dia menaik juga sebenarnya. But both of this is approaching zero. So when R is at infinity, apa ni? So for both of the graph, tak kisah ada positive charge ke, negative charge ke, apa ni? When R is at infinity, V is equals to 0. This one is a important thing. So it will try to move towards 0. Cuma satu ni decreasing, kalau daripada sini decreasing, kalau ke sini pula increasing. So it's a bit different, positive and negative tu. Tapi most likely wording dia different, but then calculation biasanya sama je. Okay, this one is the diagram lah. Dia kata benda ni sama sebenarnya daripada yang apa yang saya explain tadi based on the graph. Kalau dia mendekati, dia increase V, menjauhi V decrease. Dia terbalik dengan yang negatif charge particle ni. Kita pergi balik Kalau dia menjauhi, V dia decrease, mendekati V dia increase. So if this one going further away, V dia increase, going towards V dia decrease. Okay, example on how to calculate the V. Okay, V is very easy. 2-point charge Q1 and Q2 are separated by a distance of 15 cm as shown in figure 1.14. Calculate the electric potential at point A and then at point B. So if you want to calculate potential at point A, so basically you ignore yang point B ni tak ada kena-mengena dengan yang point A ni. So just a point. So you have to ask yourself, dekat dalam diagram dia ada berapa banyak charge yang akan produce potential. Okay, berapa banyak charge yang produce potential?
Tu.
Ada tu kan? Okay. Saya ingatkan kamu takkan bersuara. Alhamdulillah, sorry tak. So ada dua charge yang produce potential. So that one comes from V1 and V2. Okay, normally we label V1 at A, V1, V2 at A. Kalau yang kat B pun sama juga. VB, kita ada dua potential juga sebab ada dua charge. So setiap satu charge ni dia produce potential. V1B plus V2B. So the key thing here is that you need to know the R. Since V is equals to KQ over R, Q is given. Kalau ada negatif, saya ulang lagi sekali, masukkan negatif. The R means the distance from that point to the charge. So this one is actually your R1A. Okay. This one is your R1A, sorry, R2A. This one is R2B, 0.13, tukar SI unit. And this one will be your R1B. So the distance from the charge to that point. So when you try to do one by one, ignore yang lagi satu point tu. And then masukkan formula, tambah gitu je. Tak payah pening-pening, direction dia ke mana semua, you don't have to worry about direction. Ini contoh solution dia lah. So simply substitute all the values. Okay, you get the answer. Ada dalam negatif, biar je. Tak perlu explain pun. So this one same. Masukkan nilai. Cuma yang ni tricky part dia kena kira R1B dulu lah. Tak susah pun. Kira Pythagoras, dapat masukkan and then you still get the answer. Okay, the main problem student dia biasa confuse kat sini. Ada R square ke R biasa. Itu masalahnya lah. Kalau confuse juga saya tak dapat tolong lah sebab benda ni memang ada formula is given kan. So you can always refer back to your formula sheet Kalau kamu cuba-cuba ingat, salah ingat, tu memang salah sendirilah macam mana. Okay. Kita masuk work sikit and then maybe kita boleh stop kot. Okay, electric potential difference delta V. Okay, ni sebenarnya saya tak tahu kenapa dia label this one, but in this chapter actually kita nak fokus. Okay, oh dia fokus kat delta V, sorry. Betul lah ni. Okay, potential difference between 2 points in electric field is defined as the work done per unit charge bringing positive charge from a point to another point in the electric field. So the difference between this one dengan definition yang awal tadi yang saya explain banyak lebar tu is that this one is delta V. Depan saya tadi adalah V. So V definition dia from infinity to that point. Kan, ingat tak? Tapi kalau delta V dia from a point to another point. Kalau tadi daripada infinity ke 2 point, yang ni point to point. So beza dia,
Ingat sir.
okay, ingat. So dia tak ada beza sangat pun. Dia still Q delta V. Okay, it's just that V lagi satu tu bukan zero. Itu je. Work equals to Q not V final minus V initial. So what does it mean is that this one is my, if let's say I bring the positive test charge from here to here, from B to A, so it would be VA minus VB. Okay, work equals to Q naught VA minus VB. Sometimes ada student dia got confused tau. Dia confused delta V ni nak tulis delta VAB ke delta VBA. Dia confused. So biasa saya tak tulis terus. Saya fokus on this because this one is the important thing. So, you want to substitute with the correct values. Final minus initial, itu je. Subscript tu jangan peningkan kepala. Just that as long as you substitute the correct value, then should be okay. VA minus VB. So final minus initial. So student dia tengok BA ni dia confuse BA ke AB. Lepas tu dia dah confuse kat sini apa. Konsep dia satu je. Final minus initial. This one you can basically ignore pun tak apa. Apakah ini? Kenapa dia ulang 2 kali? Okay, this one dia kata what if dia kata bawa daripada A ke B pula. Tadi B ke A. B ke? Tadi B ke A, now dia kata A ke B. So obviously you can always calculate again lah. Contohnya kalau ada positive charge tadi. Tadi B ke A, now A ke B. Okay, one way to calculate it, you can recalculate delta V equals to VB minus VA. Okay, ataupun you can simply put negative. Macam ni lah. So saya tak suka pening-peningkan kepala kan. Maksudnya negatif ni sama dengan macam ni. Delta VAB is equals to negative delta VBA. Itu je maksudnya. Kalau the other way around, tolaklah terbalikkan. Flipkan dia je. So kat bawah tu dia keluar. Maafkan saya. Okay, this one actually.
Faham sir.
Faham Okay, yang ni yang salah This one is actually about work. Padam terus. About work. Apa kali pula potential tu. Okay, define as the work done bring a positive test charge from a point and a point. Okay. Ni benda yang sama sebab dia pakai benda yang sama. So actually, but in this subtopic actually kita nak fokus kepada work tu. Okay, the work done to bring charge from one point to another point in an electric field is independent of the path. So contohnya saya ada positive test charge, positive charge kat situ. This one is positive test charge. Okay, let's say saya nak bawa ke sini. Okay, it does not depends on the path that the person using lah. So dia boleh buat macam tu ke, macam ni ke, pusing-pusing-pusing ke, macam ni ke, it doesn't matter. The work done is the same. Work is dependent on V. V final dengan V initial je. Dia tak kisahlah kamu nak pusing macam mana. If the value of the work is done is positive, work done on the system. If the value is negative work done by the system. So the difference here is on and by. So on the system ni kita lakukan kerja kat atas sistem. So you need external force. Work done by the system, no external force is needed. Jadi saya explain in detail. Okay, yang ni cerita mana datang positif dengan negative values tu. Okay, kita cerita ni dulu lah. Okay, let's say you have a positive charge. Okay, charge yang tak bergerak ni, you put that one as capital Q ataupun Q je. So actually dalam formula work, kamu ada dua Q tau. This one is actually Q0 delta V. Q0 here is the charge that is moving. Yang bergerak tu adalah Q0. Okay. Inside delta V ni actually ada Q juga. Sebab dia adalah V equals to KQ over R. But this one, we call this one as the one that is fixing. This one yang fix. Tak bergerak, bergerak. So when I try to move, this one is the moving one, this one is the Q0. The one that is not moving is Q. Okay. Tolong ingat, jangan confuse. Bila kamu buat dalam exam, dia sebenarnya bila kamu darab ni, darab depan, darab belakang, sebenarnya jawapan dia sama je. Tapi make sure kamu jangan salah konsep. Sebab sometimes pemeriksa tu kalau dia particular, dia kata, oh budak ni tak faham konsep pun, buat-buat kebetulan betul. Pangkar. Sebab dia darab juga, so sama je sebenarnya jawapan dia. Tapi jalan kira tak sama. So be careful with that. So kalau gantian tak salah, jawapan akhir mesti salah. Walaupun jawapan dia sama. Consider positive charge is moved by external force. Okay. You can imagine this one dengan this one, mana satu potential lagi besar. You can always refer back to the initial graph yang saya tunjuk tadi. Kalau positif, dia macam ni bentuknya. Okay. This one is the position of A further away compared to B, a bit closer. So if I want to move from A to B, so my VB is my V final kan? V final is bigger than V initial. Right over here. So my delta V is actually bigger than 0. It's positive delta V. So if my delta V is positive, since my equation is like this, work equals to Q0 delta V. This one is positive. So Q0 in this case is positive as well. So if this 2 is positive, then work done is positive. Itu je nak cerita. Okay, in terms of positive work done, apa dia?
Macam mana kita tahu point to point B? Macam kita kena label, macam mana nak tahu?
Saya nak tahu apa?
Yang ikut graf tu, berdasarkan graf tu, macam mana saya tahu yang final dia dekat yang paling atas tu?
Okay, saya ulang kat sini. So dekat sini adalah V lawan R. So R ni the dependence on the distance. Kan? Kalau daripada graf ni, yang dekat sini bila ada kecil. So dekat dengan charge yang produce potential tu. So B ni actually lagi dekat compared to A. So tu bila saya lukis ni, saya label yang jauh tu A, yang dekat tu B. Bukan sebab gambar ni ke kanan macam tu. Dia sebab ikut distance dia R. RA tu lagi further away, RB tu lagi dekat. So kamu boleh expect RB ni dia punya potential bigger daripada potential dekat A. Kamu boleh try kira lah sebab V equals to KQ over R. R besar, R kecil je. Itu je sebenarnya.
Faham je.
Okay. Okay, tadi siapa tanya? Dani ya?
Sir.
Nak
tanya yang kan dia kan positive sign. Kalau dia negative sign, sama je lah konsep graf tu. Contohlah kan kalau soalan ni negative sign, maksudnya dia punya V yang V tu lagi besar A lah kan? Saya tak faham.
Okay, kalau dia negative side, dia mesti terbalik. Sebab dia kat belah bawah sini. Kejap lagi kita akan pergi negatif. Jadi kamu compare. Sikit lagi 2 minit kita pergi kat negatif tu. Okay, tapi before kita pergi kat negatif tu, okay, so soalan tu simpan sekejap. Jadi saya jawab. Saya just nak point out apa maksud positive charge ni. Positive work. Okay, this one is positive, so you end up with a positive work. So what does it mean by positive work is that you need to apply some external force. Okay, kalau kamu nak fikir logik, charge yang kamu gerakkan ni adalah positif. Yang tak bergerak ni positif. Okay, kamu bayangkan macam magnet lah. Kamu nak dapatkan dua magnet yang kutub dia sama, you have to apply some force. So since this polarity of the charges is the same, positive and positive, you want to bring it closer, you have to apply some work. Work done is positive. Kenapa penting kamu kena tahu work done positif ke negatif? Sebab sometimes dalam exam, dia tanya kamu apa maksud positif dan negatif tu. And then sometimes dia tak tanya pun, but then you want to check. You want to recheck kamu punya calculation tu betul ke tak. Does it make sense? So kamu kena tanya diri kamu lah. Work kamu positif, oh kamu nak dapatkan positive charge dekat-dekat, kena apply some work. Apply some work. So it makes sense. Okay, we're gonna go to still positive charge. Okay, masih lagi positive charge, cuma satu ni dia moving away. Saya lukis balik kat sini. Ini case yang sama exactly macam tadi. Dia gerak daripada jauh ke dekat, that is B and A. So VB lagi besar dari VA, dia positif. Ni explanation dia sama je dengan tadi. Kalau yang ni pula, dia masih lagi positif charge, Q yang tu ada positif, so dia still graph dia macam tu. Cuma sekarang ni dia tak gerak daripada A ke B, dia gerak B ke A. This one is your B dekat lagi, A jauh sikit. Now they move in this direction. They're moving away. Okay, what can you say is that V A is my V final, V B is my B initial. A dengan B, kalau kamu tengok from this graph, A tu lagi kecil. Okay, so if this one is smaller, so this one is your V final, this one is your V initial. So bila kamu ada data V, final minus initial, final tu nombor dia lagi kecil, minus nombor lagi besar, you get a negative. Okay. So when you have a negative here, since the work equals to Q naught delta V, this one is positive, masih lagi positive, yang kamu gerakkan tu positive. This one you get negative. So the work done here is a negative work. So negative work means work done by the system. So kamu boleh imagine, kamu ada dua charge yang sama polarity, positif dekat-dekat. Bila kamu lepaskan dia, kamu tak pegang kan, katakan kamu tak pegang, maybe dia akan bergerak sendiri. So itu adalah kerja yang dilakukan oleh sistem ni. So charge ni yang buat kerja, kamu tak buat kerja. You don't have to apply any force by itself, it will move from B to A. Itu maksud dia, negative work done. Okay, saya tahu some of you might get confused with this graph. Okay, but for me, graph ni untuk bantu kamu faham. So kalau kamu tak faham apa significant graph ni, kamu jangan risau sebab actually kamu kena kira. Dalam exam memang kamu kena kira V tu. So bila kamu kira V tu, kamu tak faham pun dia kat depan ke kat belakang, it doesn't matter. Sebab bila kamu kira, kamu dapat value dia besar ke kecil. And from there you can see whether it makes sense or not. Okay, so don't worry too much about the graph. Mungkin sebab tu dia keluarkan daripada syllabus. Sebab student jadi confused. Anyway, kalau negatif, ni soalan tadi. Saya tak tahu siapa yang tanya sebab saya tak kenal suara. Tak nampak muka kamu. So, kalau negatif, Aina, okay, sorry. Saya tak tahu kenapa bila kamu tanya soalan dia macam jauh sangat. Macam kena, apa dia? Okay, graf kamu daripada bawah sini, kalau negatif. Ingat lagi kan? So, B dengan A tu masih sama position dia. B dekat, A jauh. So, just label in advance. B dekat, A jauh. Okay. Apa dia nak cakap? Kalau saya nak gerakkan, okay, for the first case, dia gerakkan from A to B. So, this one is your final, this one is your initial. So, it move from A to B in this direction. So, you can see from here, VB kamu is less compared to VA. Sebab dia lagi bawah lagi negatif. So kecil lagi nilai dia compared to at A. Okay. So final and initial, final is at B, initial is at A. So my delta V final lagi kecil daripada initial, so I get a negative. So if I have negative delta V, I'm gonna write over here. That Q naught dia masih lagi positif, so still using the positive Q naught. Dia boleh jadi negatif Q naught tak, kamu masukkan je lah negatif. Delta V ni now is negative, so your work done is negative. So kamu nak check, does it make sense or not? Positive charge, negative charge. Sekejap saya baca balik. Negative, VB, work done is negative, okay. From higher to lower potential, sekejap. Oh betul lah, saya tiba-tiba saya confused. Okay, work negative means work done by the system. So kalau kamu ada charge dekat sini dan dekat sini, basically dia opposite charge. Kalau kamu biarkan dia by itself, they will try to move closer. Yang buat kerja tu adalah system ni. Charge ni yang tarik charge tu. Macam tu lah maksud dia. So negative here means work done by the system. You don't have to apply any force. It can move closer together. Okay. So ini contohnya lagi satu pula. Now dia kata bergerak daripada B ke A. So we move from B to A. From here you can see that my V at A is actually bigger than V at B sebab dia lagi atas daripada dekat B. Okay, my final is bigger than my initial. So my delta V is positive. Final tolak initial kan? Positive. So my work done is positive as well. So this one is positive. This one is positive. So my work done is positive work done. Means that you have to apply some force. Trying to push yang positif ni further away daripada negatif. Sebab kalau positif negatif dia nak menarik kan. So kalau kamu nak jauhkan dia, you have to apply some force. It makes sense. Okay. Kalau kamu still tak boleh tangkap idea, jangan risau. Sebab dalam exam yang penting sebenarnya kamu kena clear dengan betul. And then you just have to state, paling-paling pun you just have to state whether positive tu work done on the system or by the system. So kamu boleh hafal je sebenarnya, tak masalah pun. Ini contoh soalan. Sempat tak kita nak discuss? Macam tak sempat. Tapi saya just explain macam mana nak tengok. Okay, before kita pergi example yang tadi tu, yang tanya soalan tadi faham tak? Dan yang tak tanya soalan faham ke tak apa maksud saya ni?
Faham, sir.
Faham.
Faham ke?
Okay, good. Faham. Okay, soalan example 1.7. Saya nak point out satu benda. Yang soalan A ni, dia kata, okay, ada dua point S dengan T located around a point charge of this. So ada satu charge je, yang S dengan T adalah point, dia bukan charge. Dia adalah dua position, yang dia adalah charge. Calculate the electric potential difference between S dengan T. So soalan satu ni, they want you to calculate delta V. When the question want you to calculate delta V, kamu boleh buat S minus T ataupun T minus S, dia tak kisah. Okay, if you do it like this, satu tu kamu akan dapat positif, satu tu akan dapat negatif. Kepadanya lagi satu lah. So saya just tulis dia macam ni. So dua-dua jawapan dalam exam diterima. If the question just state potential difference, that means the question want to find delta V. Tak perlu pening mana tolak mana, just tolak je. Dua-dua jawapan diterima. Kalau ada negatif, biarkan dalam negatif. Okay, but Dalam exam, most likely dia akan ada follow up question. Follow up question biasanya dia akan tanya pasal work, and because naturally they will ask work equals to Q delta V lah. So my suggestion is that you read the question sampai habis, baca soalan yang work tu, dia nak gerak daripada mana ke mana. Okay, yang B ni, okay, yang A ni senang je lah. Dia V equals to KQ over R. So kira V dekat T, kira V dekat S, tolak. Macam tu. Yang B ni, the work done in bringing a charge of negative 1.9 coulomb from T to S. So here dia kata tiba-tiba, tak ada tiba-tiba, dia letak satu charge, test charge, tapi test charge ni negatif. Tadi yang contoh saya tunjuk tadi semua positive test charge. Here is an example of negative test charge. Tak ada masalah pun. Charge ni yang bergerak. Okay, so this one you have to substitute with Q naught. So you move from T to S. Draw an arrow so that it makes you easier. So when you try to calculate this one, work equals to Q delta V. Delta V that you want to use is V final minus V initial. So you will expect this one equals to Q naught V at S minus V at T. So my suggestion is that if this one is Vs minus Vt, might as well over here you calculate Vs minus Vt. So that when you try to do B, dia senang je. Kalau kamu kira Vt minus Vs ke atas tu, you can still use that value, you just have to put negative. Kalau dia asalnya ada negatif, negatif lah, positif. Okay, kita tengok contoh jawapannya. Okay, ini adalah soalan A, dia nak calculate delta V. Mana pergi delta dia, saya tak tahu. Kena malas nak buat, saya buatkan. So VST, kalau kat sini dia buat ST tau. T minus S. So jangan risau pasal ni, dia buat T minus S. So dia dapat nilai negatif. Tapi remember, untuk soalan B, dia nak kira S minus T. S minus T. Dia kira T minus S. Apa yang dia buat, dia negatifkan benda ni. So benda ni dah negatif. Negatif lagi, saya kira dia jadi positif. And I don't know why you're not insisting on using this form. Biasa kita pakai work equals to Q delta V. Hilang lagi delta dia. So dia letak negatif. So ini bagi saya kiraan yang kurang produktif lah, sebab kenapa kamu nak buat macam tu kan, nanti kamu terlupa letak negatif, habis terus. So might as well masa yang kat A tu kamu buat jadi S minus T untuk A, so that kamu boleh pakai nilai tu straight away untuk kira yang B. And then remember, Q naught tadi ada negatif. So negatif, masukkan je negatif tu, kamu dapat nilai ni. So you can always recall, nanti tengok balik calculation ni betul ke tak. And then you will see that work done is negative. Kalau negatif tadi maksudnya apa? Work done by ke on system?
By.
By system. Okay. Siapa yang buat kerja? Sistem buat kerja. Kita tengok, does it make sense or not? Kamu ada positive test charge kat sini. Positive charge kat sini yang tak bergerak. Kan? Yang bergerak tu negative charge kat situ. Okay. So, from here to here, sebenarnya jarak dia makin dekat ke makin jauh? Kamu kena tengok jarak dia yang ni sini. R initial dengan R final. Mana lagi dekat? Final ke initial? Final kan? It make sense lah. Satu ni Pythagoras, satu ni apa tu? Apa nama dia? Saya dah tak ingat nama dia. Satu ni jauh, satu ni dekat. So kamu nak dekatkan negative charge dengan positive charge. So kamu perlu tak apply work. Kamu perlu tak apply force untuk dekatkan charge yang opposite charge.
Perlu. Opposite charge tak perlu.
Tak perlu kan? Sebab tu dia adalah work done by the system. So system ni yang tarik benda tu. Walaupun patutnya tarik ke sini lah kan. Tapi maksudnya contohlah. So bila kamu nak bring two opposite charge together, the work done is by the system. You don't have to apply any external force. Okay, itu maksud dia. Any question?
No, sir.
No.
Okay, kalau tak ada, kita berhenti sini. Kita jumpa dekat lab. Lab berapa saya tak ingat, kena check balik. Okay. Jangan lambat Kita mula. Lepas tu ingat dekat lab, saya tak nak cakap apa-apa tau. Kamu masuk lab, kamu buat je terus.
Sir, kalau contoh nak tanya sini boleh?
Tanya apa? Masa lab ke sekarang?
Masa lab boleh tanya ke sir?
Tak boleh.
Tak boleh.
Dia tak nak interaction. Saya duduk di jauh, kamu buat je. Kamu tanya labmate kamu. Kalau tak
Kalau
faham,
jerit-jerit boleh lah.
jerit-jerit. Nanti terkeluar dia. Tak apalah. Tengoklah nanti kita tengok macam mana. Tapi the main thing is that datang, buat eksperimen, collect data, lepas tu boleh throw balik. Buat table, isi dalam table, lepas tu boleh throw balik. Okay, kita jumpa lagi. Okay, thank you.
Thank you, sir.
Okay. Alright.
Thank you.